Hello, welcome to our class on past exam papers analysis. Here we shall look at questions on February-March exam 2018 IGCSE 2018 Additional Mathematics paper 1. Basically, we shall focus on problems involving differential calculus in this exam. Let us proceed. Here we have question 2, which involves differential calculus, and we are told that a curve has the equation y equal 4 plus 5 sine 3x. Question Roman figure 1, find dy dx. dy dx means we are required to find derivative of y with respect to x. Now recall we are given that y equals to 4 plus 5 sine 3x. Now let's recall the basic rules of differentiation. Now this can serve as a guide to solve this problem. If we have sine x, dy dx, derivative of sine x gives cos x. If you have cos x, derivative of cos x gives minus sine x. And when we have tan x, the differentiation gives sec squared x. Now what of when we have a value that does not contain x? For instance, let's say k. K doesn't contain x, then dy dx derivative of k will be equals to 0, since the initial function does not contain x. Very important. Now, it implies that y equal to 4 plus 5 sine 3x can be differentiated as follows. Dy dx will be equal to, when we differentiate 4, the first term here, differentiation of 4 will be equals to 0, since 4 does not contain x. So it serves as a constant. Is that clear? Plus, let us find the derivative of 5 sine 3x. The method to do this is to first differentiate 3x. Let us differentiate 3x with respect to x. If we differentiate 3x with respect to x, we have 3. So the result comes behind the trigonometric function. Then that will be used to multiply 5. That's 5 times 3. Now don't forget that derivative of sine is actually equals to what? Cosine. So derivative of sine 3x is cos 3x. So I'll write cos 3x. So invariably, differentiation of sine 3x is 3 cos 3x. How is that achieved? We differentiate 3x, we have 3. Then we multiply it by the initial question, which is sine 3x. Not forgetting the 5 behind the function. Now dy dx will now be equals to 0 is insignificant. So we have 5 times 3, that's 15 cos 3x. And that is the result of the derivative of that function, dy dx, 15 cos 3x. So it implies that I can add up here that derivative of kx will simply be equals to k, right? For instance, differentiate 5x, it will be 5. Let us proceed to question Roman figure 2. In Roman figure 2, we need the result of Roman figure 1. Don't forget, the result of Roman figure 1 says dy dx is actually equal to 15 cos 3x. That is derivative of y equals to 4 plus 5 sine 3x. The derivative of this function gives 15 cos 3x. So we need that result. Here we are required to find the equation of tangent to the curve y equals to 4 plus 5 sine 3x at the point x equals to pi over 3. Finding the equation of tangent to the curve. Now, one thing we need to understand is that a tangent to a curve is actually a straight line that touches the curve externally at only one point. Let us assume this is a curve. If that is a curve, then a tangent to a curve must touch the curve externally at only one point. Now take a look at this. That is a tangent to the curve. The tangent to the curve touches the curve externally at only one point. So it touches it here externally. Sorry, my annotation didn't get that perfectly, but take note that it touches that externally at only one point. Now the line here is called the tangent line. So that is the tangent to the curve. So basically, a tangent to the curve is actually a straight line. In real sense, we are required to find the equation of that tangent, means that we are required to find the equation of a straight line. So let us find the equation of a straight line, which is the tangent line. Now the equation of a straight line is giving us y minus y1. There are several equations of a straight line anyways, but we can make use of y minus y1 equal m into x minus x1. And that is the required equation of a straight line we shall be using to solve this question. Now m here denotes the tangent to the line. So m is called the tangent. Sorry, m here denotes the gradient of the line. M is called the gradient of the line. So first, let us find the gradient of the line. The dy dx obtained earlier will be used to obtain the gradient of the line. Now we have dy dx simply means gradient, our introductory concept that dy dx simply means gradient or the slope of a line. So dy dx for y equals to 4 plus 5 sine 3x has been obtained to be 15 cos 3x. So let's now obtain a value for that gradient. Now dy dx, which is the gradient and denoted by m, we want to obtain the gradient at point x equals to pi over 3. Gradient at x equal pi over 3. Let us do that. And this will be equal to 15 cos 3x. This will be equal to 15 cosine function 3 times x is now pi over 3, so we need to substitute pi over 3 for x. And this will be equal to 15 cos multiplies 3 times pi, that's 3 pi over 3. 3 at the numerator cancels 3 at the denominator, we have 15 cos pi. Now observe that this is actually trigonometric functions. For trigonometric functions, pi is giving us 180 degrees. Pi is 180 degrees. So we have 15 cos pi. That's 15 cos 180 degrees. Cos 180 degrees is minus 1. You can input that into your calculator. Now this will be equal to 15 times minus 1, and that will be equal to minus 15. And this is the gradient value. Now required equation of tangent at the point when x is pi over 3. At the point when x equal pi over 3, we can get a corresponding coordinate for y. Don't forget, the equation of the curve is y equals to 4 plus 5 sine 3x. So To get a corresponding value for y, we have y equals to 4 plus 5 sine 3x. At the point where the line is tangential to the curve, x is pi over 3. So let us substitute s equals to pi over 3. We have y equals to 4 plus 5 sine 3. Instead of x, we replace that with pi over 3. So we have y equals to 4 plus 5 sine 3 at the numerator cancels 3 at the denominator. We have 4 plus 5 sine pi. For trigonometric functions, pi is 180 degrees. So we have sine 180 degrees. We can input that into our scientific calculators. And that's 0. Sine 180 degrees is 0. So we have, this gives y equal 4 plus 5 multiplied by 0. And y equals to 4. So the coordinate system at the point tangential to the curve is x equals to pi over 3. Corresponding value of y is 4. Now this is required to obtain the equation of tangent to the curve, which is actually a straight line equation, and the gradient m equals to minus 15 is required. Also, the formula for equation of tangent, the required straight line. So I'll write that point out. The points required: the coordinate system x and y, pi over 3, 4. The gradient m is minus 15, and now we have, don't forget, the equation of a straight line is an equation in terms of y and x. So there won't be a substitution for y and x. We only substitute for other parameters in the equation. So here, this automatically serves as x1. Then the next coordinate here serves as y1 at the tangent. Now we have y, no substitution for y, minus y1 is 4 equals, the gradient function is minus 15 into x minus x1 is pi over 3. We have y minus 4 equals to, we can open up the bracket, minus 15 multiplies x, that's minus 15x, minus 15, negative 15 multiplies negative pi over 3, negative negative is positive, that's 15 pi over 3. We have y minus 4 equals to negative 15x plus 3a1, 3 in 15, we have 5, plus 5 pi. Now we can decide to transfer negative 4 to the right hand side of the equation. That turns to plus 4. So y equals to 4 minus 15x plus 5 pi. Now y equals to 4 plus 5 pi minus 15x. This is the required equation of tangent or equation of straight line. Now we have y equals to, we can input 4 plus 5 pi into the calculator. We have 19.71. And at this point, pi here is not actually 180 degrees. Pi is 22/7 because 5 pi is just a single value and not a trigonometric function. So input 4 plus 5 pi into your calculator, you have 19.71 minus 15x. And this is the required equation of tangent. Final answer, y equals to 19.71 minus 15x. Or you can write it in the standard equation of the straight line to look like y equals to ms plus c. We can decide to write y equals to negative 15x plus 19.71. And this is the required solution. So here we have the solution to Additional Mathematics IGCSE 2018 Paper 12 February-March exam. Question 2, which is on differential calculus. So let's see in a separate video if we still have another question on differential calculus, and we'll provide a solution to it. In our class, we'll be able to learn the rules of how to carry out differentiation of various functions, and when we see this question in exam, it will be very easy. Thank you for listening. I am Sulaiman.